Hello viewers, in today's class we are going to discuss two very important problems from conic sections related to the conic section hyperbola, right? So here we'll solve two problems related to finding out the equation of a hyperbola using certain conditions, right? So let us take these problems one by one and we'll see the important results which are used to find out the desired equation of hyperbola, right? So in the first problem we have to find the equation of a hyperbola if the distance between the foci is 16 and its eccentricity is square root of 2, right? And in the second problem we have to find the equation of the hyperbola if the length of the lattice rectum and the length of the transverse axis are given as 4 times the square root of 3 and 2 root 3, right? So let us take the problems one by one. So in the first problem, let us draw a rough diagram, right? So here we have the x-axis and here we have the y-axis, right? Okay, now let us draw a rough diagram of the hyperbola. So let us take the hyperbola like this here and similarly here, right? And here we are given the distance between the foci is 16, right? So the coordinates of the focus are f1. So here we have c comma 0 and here we have f2 and the coordinates are minus c comma 0, right? So here we are using the usual notations, right? So f1 and f2 are the two foci of this hyperbola, right? And x-axis is the transverse axis and y-axis is the conjugate axis, right? And now the distance between the two foci, that is f1 f2, right? So the distance between f1 and f2 is equal to 2c, right? Because see, this distance is c, right? And this distance is also c. So the total distance between the two focus is f1 f2, that is equal to c plus c, 2c, right? And here we are given the distance between the foci is 16, so 2c is equal to 16, right? So the value of c is 16 over 2, that is 8, right? Okay, now let us make use of the second condition. So here we are given the eccentricity of this hyperbola is square root of 2, right? So now we know that the eccentricity is defined as E is equal to C over A, right? So this is the definition of eccentricity of hyperbola, right? So here the length of the transverse axis is equal to 2A and the length of the conjugate axis is equal to 2B, right? So here we have these two coordinates are minus a comma 0. This point is a comma 0, and here we have the coordinates 0 comma b, and here we have the coordinates 0 comma minus b, right? So E is defined as the ratio of C and E, right? So now E is given as square root of 2. So here we can write square root of 2. C is 8 and here we have A, right? So now A root 2 is equal to 8, taking A to this side. So A is 8 over root 2. Rationalizing it, we get 8 root 2 over 2, so 2 fours are 8, so a is equal to 4 root 2, right? Okay, so now we have to find the value of b, right? Now we know that in hyperbola, the relationship between A, B, and C is given by C square is equal to A square plus B square, right? And now uh, we wish to obtain the value of B. So B square is equal to C square minus A square. So C square is 8 square and A square is 4 root 2 square, right? So now we have 64. Here we have 4 4 is 16, 2 is 32. So here we have 32, right? So B is a square root of 32. So B is 4 times square root of 2, right? So now the value of B is also equal to 4 times square root of 2, right? And now we know that the standard equation of a hyperbola whose center is the origin is given by x square over a square minus y square over b square is equal to 1. So we have x square over a square. So a is 4 root 2. So a square is 4 root 2 square, that is equal to 32. So here we have 32. Then we have y square over 32 because b square is also equal to 32, right? And this is equal to 1. So we have x square minus y square over 32 is equal to 1. So we can also write this equation as x square minus y square is equal to 32, right? So viewers, the standard equation of this hyperbola, the distance between the foci is 16 and the eccentricity is given as square root of 2, is given by x square minus y square is equal to 32, right? So now let us consider the second problem. So here again we have to find the equation of the hyperbola. The length of the lattice rectum is given as 4 times square root of 3, right? Now see, the lattice rectum L is given by 2b square over a, right? So the formula for finding out the length of the lattice rectum is equal to L is equal to 2b square over a, right? And the length of the transverse axis is 2 root 3, right? So the length of the transverse axis is given as 2a, right? So here we have to make use of these two results to get the equation of hyperbola, right? So now the length of the lattice rectum is 4 root 3. So L is given as 4 root 3 and the length of the transverse axis is given as 2 root 3, right? So now here we take 4 root 3. So we have 2b square over a is equal to 4 root 3, right? And from here we can write 2b square is equal to 4a root 3. So this 2 and this 4 get cancelled. So we are left with b square is equal to 2a root 3, right? Okay, now here the length of the transverse axis is 2a. So now we can equate 2a is equal to 2 root 3. So this 2 and this 2 get cancelled. So we are left with a is equal to root 3, right? And if we take this a is equal to root 3 in equation 1, we get b square 2 times root 3 times root 3. So b square is now 2 times 3. Root 3 times root 3 is 3. So this is 6, right? So b is square root of 6, right? And a is equal to square root of 3, right? So now here we can easily see that b is greater than a, right? Because square root of 6 is greater than square root of 3, right? So the standard equation of this hyperbola is given by x square over a square minus y square over b square is equal to 1, right? And we have x square over a square. So a is root 3, so a square is 3. So here we have 3 minus y square over b square. So we have y square over b square is 6, right? So here we have 6 and this is equal to 1, right? So the standard equation of this hyperbola with these conditions is equal to x square over 3 minus y square over 6 is equal to 1.